My name is Sunil Agarwal. I'm a program manager with SQL Server team. And I've been involved with this column store technology for the last 2 years. And we are really excited about what it can do for your workloads. As part of this release, 2016, we worked with many, many customers who have used this technology successfully in their production workload. So we felt it's a good idea to bring those customers to Ignite and let them talk directly about their workload to you guys. And you can see firsthand a real-world application running with 2016 column store technology. So I'm really thankful to customers, Mika from M-Files, Sonica from First American, and Yunus representing Damon. It's a health insurance company in UAE. So I really appreciate their time. So what I will do is I will introduce the technology at a very high level for first 10 minutes. And then I will invite each of our speakers for 20 minutes to talk about their workload, the numbers they got, stuff like that. And I think the best will be you ask any questions to them because they are the people who have deployed this technology in production. So feel free to ask any questions. And if there is more questions, we will take those questions after the talk. So in this session, the main objective is to make column store real for you as much as we can, but showing you the workload. The key takeaway from this session would be, I hope I can convince you that the column store technology is the industry leader for analytics workload. When I say industry leader, we are talking HANA, Oracle, Sybase, DB2. We beat them all, okay? And I'm going to show you some evidence on that. And second thing is, our customers, the customers who are here, they are able to get a competitive edge using this technology in their workload. So this is my agenda. I'm going to give you the benefits of column store, and then we'll just walk through each customer. So let me ask you first question. How many of you know about column store? It's actually around 80%. I did a presentation on Tuesday which goes through the basics of column store. And I'm not going to repeat that content, but I'm assuming you know column store. But one demo that I want to do, a very quick demo for you to show the power of column store. Okay. You see that? Okay. So what I have is a AdventureWorks data warehouse database that you see here. Let me make it like a little bit bigger. Let me make it 120. You can see in the back? Yes, okay. So what I have is a typical data warehouse where I have a star schema. So you have a fact table and multiple dimension tables, right? That's a very standard data warehouse. And what we do before you use column store, the technology was using row store, right? Traditional way you store the data in a table. And I'm going to run this query. And look at this query. It has 3 joins, right? I'm joining a fact table with 3 dimension tables. And let me start the execution on this thing. So now this is doing 3 joins. This fact table has around 11 million rows. I'm not saying it's a big fact table, but it's a representation. And this query will take approximately 30 seconds, okay? Not bad, 30 seconds. And what I want to show you is that I'm going to just create a column store index on the fact table. That's all I'll do. I will not change anything. I'm not going to go to different machine, same machine. I just create the index. And you will see the performance of this query goes up significantly. Okay? So that's a key value proposition. No changes to your application, and you can get much, much better query performance. So you saw this query ran at the bottom, if you see, around 24 seconds. Everybody can see that? This is 24 seconds. So what I did was, before I came to this talk, I just said create clustered column store index on this table. What it does is it removes the row store and makes it column organized. And if the fact table had a cluster index before you ran this command, you have to say create cluster column store index, drop existing, right? That's all you do, okay? And then I run the same query. So here, exactly the same query, and notice the fact table that I have, I just actually have a copy of that table in the column store format. It is called fact seller reseller underscore CCI, which is clustered column store index, right? Let me run this query. And you will see that this query will run like in 2 seconds. So from 24 seconds, I went down to 2 seconds, which is like 12 times better performance. So that's the promise of this technology. You can speed up your analytics in a very significant way with least amount of work, okay? Not only you get such a good query performance, you get amazing amount of compression, okay? So I'm going to show you the space used. So the first is SP space used for fact table in the row store, and the second one is with the CCI. And you will see the row store was taking around 2.5 gigabyte, and with the column store it is taking around 700 megabytes. So I got 3x compression. Now the compression depends on the schema and the data pattern. Typically, you should expect around 10 times compression. So that's again, you not only save on your storage, you get significant boost in your performance. So now let me switch to the deck. So where we are, when I say we are industry leader, the TPCH is an industry standard benchmark for analytics workload, okay? And you will see in this block that for this 10 terabyte data warehouse, 10 terabytes, SQL Server has the top 7 numbers, okay? So in 10 terabytes, if you look at the benchmark, SQL Server is the top 7, okay? So that's the power of this technology inside SQL Server. And if you look at 30 terabytes here, that's again, you can run column store on a single box, SMP. And again, we are the leader there. You can see with 2016, we are leading there. So again, this is a market leader technology. And the next thing that I want to show you is we are investing in this technology in a big way. We invested this technology in 2014. We made significant investment in this technology in 2016. And one slide to show you what we have done. We have done improvements for performance. Some of the things are like string predicate pushdown. They may not mean much to you here, but I just want to impress upon you is that we have done significant investment in improving performance, in improving functionality. For example, we introduced now a non-cluster index on a cluster column store index. That is something I talked about on Tuesday. And we also enabled the real-time operational analytics. What it means is in many workloads, you don't have to do ETL. You can run your analytics directly on your OLTP workload. And we have actually invested in how do you minimize the impact on the OLTP workload while still running analytics. So this is a very broad brush to show you what we have done with 2016. So here's the interesting thing. Since we did so much investment, we said let us run a performance of TPCH benchmark on 2014 and run the same benchmark on 2016 on the same hardware and see what we get. And what you see here is that on 2014, this is 2014, we were getting around 700,000 queries per hour. Same box, I just upgraded to 2016, I'm getting 970,000. So that's a 40% improvement in the performance just by upgrading, right? So what I'm saying is, if you're using 2014 and you're happy, and if you want to become happier, move to 2016, right? Okay. So that's all I wanted to say. And now I wanted to introduce Mika, and Mika is a senior director in M-Files. And Mika and myself have worked very closely together to bring this technology into their application. So Mika, here you are.
Yeah, thank you. It's quite difficult to compete against FreeBoost, but I think we did fairly well. Yeah, I'm Mika Javanen. I'm a product manager at Emphasis, and I wanted to spend 20 minutes to discuss a little bit about what we did with columnstore. And value prop that we are trying to solve is that oftentimes documents and information is managed in folder-like hierarchies. So if you think about network folders or even SharePoint, you often have and then you might have okay, good. Can you hear me now? Yeah, I'm pretty sure that guy over there woke up, so that's good. Yeah, oftentimes you end up managing information in folder hierarchies or something like that. So even if you think about the new products like Box and Dropbox and so forth, they're basically network folders in the cloud. And the challenge is that then as a user, when you save a document to the system, you have to know where should I store this. So this is kind of like the problem that we are trying to solve with our product. To where we are leveraging metadata, so the user is actually only going to tell our system, okay, so what is this document I'm working with? So in this case, it's a proposal, it's related to a customer, to a project, it will expire in 2 weeks, it's maybe accepted, maybe it's not, and so forth. And then based on that, different users will be able to browse the content in whichever way they want. So if you're in a project team, you may want to view your proposals by project. If you're in let's say sales team lead, you want to see, okay, how many proposals did we create last month, and so forth. So very similar to the concept of views, for instance, in SharePoint, but the difference is that this will work across the whole database repository. And now oftentimes you end up having millions of documents in one database. So what happens in Emphasis when you save a new document to the system, we'll actually create a SQL transaction of about 60 SQL queries and commit that. So we'll create about 60 inserts to different tables within the database. And now if you change some metadata, that can actually trigger additional business processes, so it can trigger multiple assignments or workflows and so forth. So of course, that can then result in even hundreds of queries or inserts to the database. So to us, it was very critical that these OLTP queries are not interfered if you implement some improvements to the OLAP side of things. So the requirements for us as we started looking into this was that we have to be able to complete those metadata updates in less than 1 second. And then if you do these mass updates, typically it should complete in less than a few seconds. Sometimes it can take a little bit longer, but anyway, that's kind of important to us that those updates are fast. And then, of course, those view listings or folder listings that we are talking about must be produced real time. So as Sunil was referring to us, it was not an option to look at like ETL or like having 2 different database structures, one for the OLAP queries and one for the transactions. We have to be able to work within the same database. The real challenge for us is, as I mentioned, we have 7,000 customers, and the metadata structure in Emphasis is very flexible, so each and every database look very different. So the solutions that we need to be looking for need to be very generic. You cannot really go and troubleshoot one customer and try to solve that, because then you have to do the same thing for those 7,000 others. So we were really looking at generic solutions. So customers started pushing us that, we had a recommendation for M5s that, okay, in a database you shouldn't exceed 5 to 10 million objects there, because then that actually started slowing down the OLAP queries. Otherwise we were doing fine, so full text search indexes and stuff like that were working perfectly well. But then the customer requirements are of course very, very challenging, and everybody understands that the enterprise customers are dealing with increasing amount of data every year. So you cannot just stop developing and wait until the customer demands will go up, so you have to keep developing your product in every release. And it was really the OLAP queries that became a bottleneck in the system. And as I said, we had to be able to use the real-time queries in there. So what we did is actually we started, of course, typical product managers, you start looking at what's new and shining there. So you start looking at different technologies like NoSQLs and so forth, and think, okay, that should maybe solve all of our problems. So we did take a look at those as well. For us, the problem was mainly that we rely on the transactionality of SQL Server quite a lot. So if we moved into a different technology, then we would have to implement the transaction handling within the software, instead of now we can use the commits within the SQL database and kind of like rely on that. And then the second problem was that we basically use the same code base in on-premises as well as in the cloud. And in the cloud, we are using the Azure SQL. So we want to have something that works in both workloads, both in the cloud as well as in on-premises. So what we actually did in 2014 already, we took a look at the column store indexes back then, but the problem for us was mainly that you couldn't actually update those indexes, which, we couldn't then, of course, leverage that technology, because you have to be able to update metadata. Customers would get quite unhappy if you cannot update your metadata properties. And then, so we met up with Sunil and his team in Redmond and discussed this problem, and then they said, you know what, we have something really cool coming out, and it's like column store indexes that you can actually update. So that's what we actually then ended up going with. And for us, the key was that, of course, like no changes to the application, as Sunil was demonstrating. It doesn't require any changes to the code. So very key to us. We are limited in terms of R&D resources. We don't want to be spending time and money on things that don't add any value. So, of course, if there's something out of the box, you want to be able to use that. And so this is what we went with. So M5 now leverages this technology both on-premises as well as in the cloud. And the results were actually very impressive. So, is it actually working? Yeah. So the environment we tested this upon contains about 77 million rows of per table data. We had 5 tables in these benchmark queries. It's about 5 terabyte database before implementing the indexes and compression. So not all of our customers have this big database, of course, but just gives you an idea how this can work out for us. We were a little bit worried about the OLTP performance. So if you start using this, does it actually affect the performance of the OLTP? But the impact was really less than 5%, so that was really acceptable for us, because it's not really a bottleneck within our system. But then if you look at the query performances, here are 2 typical views or listings that you can perform in M5s. So the first one is that if you have millions of documents and then you want to retrieve contracts and divide them by the pricing type and agency. So before implementing this, it took 6.5 seconds. And now we just updated the indexes, and now it went in less than a second. So 0.5 seconds, pretty impressive 13 times or 13x improvement in there. We also had experiences to where if you start, for instance, using the date functions and things like that, so dividing contracts by year and month, those kind of things, there the results were even much more impressive, so from 2.6 seconds to 0.05 seconds. So these are exactly the results that the customers want to see, and the solution for them was many times, okay, we just said, okay, go ahead and upgrade your SQL to 16, and this is what you're going to get. And finally, just to give you an idea how those view listings are retrieved, so I'm not going to read this out loud to you, but you can see that this is kind of like a typical query that you would do, or M5 server would do against a database. So there are joins, quite a few joins there, and of course aggregate queries. So this is really more to provide you an idea how a typical query would look like. But all in all, super happy with the experience. Didn't impact our roadmap a lot because we don't have to change the application, and of course this was a really pleasant moment for me to sell to customers as we were updating the product and say that now you upgrade to new M5s, and this is what you're gonna get, and of course customers like to see these big numbers, so very happy with the update. Keep doing or keep improving the product for us.
So any questions for Mika? I have few comments to make, but would like to take questions on this workload. Okay, Friday.
It must be a Finnish audience because nobody's asking any questions.
How seamless was the upgrade from earlier versions of SQL?
You mean now the upgrade of from 14 to 16? Or, yeah. Well, so for different customers, of course, different. If somebody starts fresh off, then they will start directly with the 16. But even for existing customers, we didn't really hear any negative feedback on that. So very seamless. So no issues.
That's right. So one point I wanted to bring up here is it is a common confusion. So the column store is the technology, right? We provide two flavors of column store. One is the clustered column store index, which is used for analytics, right? If you have star schemas, you're doing ETLs, you go with clustered column store index, and that index was introduced in 2014 and it is updatable. The second index is non-clustered column store index, right? Clustered and non-clustered. The non-clustered column store index was introduced in 2012, but it was read-only, and it was read-only even in 2014. Okay? Only in 2016 we made this NCCI, non-clustered column store index, updatable. So now what you have a transactional workload that Mika was talking about, right? You have your metadata inserts and updates. Those are transactional workload, and they wanted to do analytics in real time, the complex query that Mika was showing. So that query runs against the column store. So if I go back, if you show me this thing, this is actually quite interesting. Okay. See, you see in the bottom here. So this thing that you see, this was the blue and above. This was their OLTP workload, right? All they did was created a non-cluster column store index that I'm showing you through this red stuff, vertical. That's all they did. It's just another index. Done. And you saw the numbers, the phenomenal numbers, like huge amount of gain. Another thing you might have missed, actually I noticed, is the benchmark that was run was 77 million rows. Remember, M-Files was saying to their customers, if you have more than 5 to 10 million rows, don't bother. But now they ran the benchmark, which is 5 times more, or actually 7 times more. So yep. That kind of performance we are seeing. So it's pretty exciting to see this thing in action. And a lot of people ask us, hey, if you create a non-clustered column store index on my transactional workload, what is the impact? And what they saw was less than 5%, right? So it is almost like best of both worlds, right? No ETL, real time, no changes.
Yeah, and of course for us as a business, it's pretty huge when you can kind of like, up your promises by 10x. So, if previously we had to say that, okay, 5 million documents really where you should like, start looking at a second database now if it's 50 million, that enables us so much more additional business that we can close. So very, very big impact on the business side of things as well.
So, Mika, can you talk about the cloud part? Because that's a strong value proposition for SQL Server.
Yeah, good
so
point.
It is like a VM or it is SQL Server database as a service?
It's a SQL Server database as a service, so we use the worker roles and the PaaS, cloud compute. So that was a huge for us because actually NCCI was introduced in the cloud before on-premises, and we had some customers in the cloud who started experiencing some problems with some of the view queries, and now to be able to actually release and roll out this update before SQL Server 16 even hit the market was pretty huge to us. So super happy about that because, of course, we are about 100 people in R&D, so we are not a huge company. So if we had to kind of like start developing a separate thing for the cloud and then for on-premises, we would be wasting the resources on things that we shouldn't be focusing on.
That's right. So this actually is a very strong value proposition from Microsoft. Cloud first is our development strategy, same code base. We expect that you're running on the box because not everybody will move to the cloud on day one. It's a hybrid scenarios. So you can run the same code on box and on the cloud. So pretty exciting. Any other questions? All right. Vika, thank you.
All right. Thanks a lot.
So the next speaker is Sonika. She is a DBA architect in First American, and we engaged with First American as part of our SQL TAP program, the technology preview program. And they actually they did a POC with non-cluster column store index as well as cluster column store index, and they found pretty amazing numbers. And here is Sonika to share her experience.
Hi, everybody. I'm Sonika Kindra from First American Corporation, and thank you, Microsoft, to give me the opportunity to present the success story that we've seen with columnstore. Our business problem was that our application was very slow. The query response times were very slow, and the user experience was not optimal. And when I first came in or was given this problem, I was said, things are running in minutes, who's going to be buying this kind of data? And we had to bring down the response times from minutes into seconds. We have 150 million properties in United States, and each of this property has got 150 attributes. So think about it. We have 150 million rows in one denormalized table and 150 columns. And the problem that we had was we had to make a dynamic search across these attributes or columns and in any different permutation or combination. So for example, our attributes are bedrooms, bathrooms, living square feet, current home value. So the user could go and make the search with any of those 150 columns, and the response time that was expected was instantaneous. So we have two kinds of queries that run on our database. One is a record retrieval, and the other one is the count query. The count query is extremely sensitive to our business because the application tells the user about the number of records we have for his search criteria, and the counts are sensitive to the search criteria that is being added and or being modified. So the user comes in and says, give me all the properties in the United States. We tell him it's 150 million. Okay, what are the properties that are currently listed? We say, oh, there are 5 million. Out of those listed properties, how many are in foreclosure? We say there are 2 million properties in foreclosure. How many of them are in the zip? And we go down to 8,000. So it's that kind of chatty application that's building the counts runtime, and the user needs to see these counts absolutely instantaneously. Because we have this property database, we also have geospatial queries in our database. And the spatial indexes, we have this map interactive queries which need to blend with other data elements. So for example, we have a polygon across a subject property, or we have a radius search across a subject property, and we blend with other data elements, again, like our lovely bedrooms and bathrooms and building square feet, or give me all the houses around the school district in a 5-mile radius because my kid needs to go to that school district and I need to buy a house there. So the challenge was that we had spatial index queries, we had full text index queries for our owner name searches, and we had 150 other columns, and all of that blending had to happen instantaneously. There was no concept of a static criteria or a static query. We couldn't get away with saying, okay, let's make our 15 indexes there and get instantaneous response times, because that was not what our problem was. So there was a point where we thought, let's go and create an index in every column and see how does the application perform. We went and we created the index. We went and we created 150 indexes. And then the performance was not the best. I remember it was at 8 seconds. The optimizer was taking the right execution plan. The worst thing was the ETL. How could we do nightly updates? That was not a possibility because 150 index creation on a nightly basis, I wouldn't have slept. So you know what? I said, that's not something where we wanted to go. So the requirements that were given to us, and my boss is sitting in the audience who says 95% of the queries should be less than 5 seconds. I can live with few queries at 10 seconds because sometimes the users, they take up around 25 attributes to build their queries. And sometimes the user, a novice user, goes and says, give me loan mortgage amounts between 0 and 9999, last sale price between 0 and 999. And the real estate user can go anywhere. And so some of the queries was fine. They could be at 10 seconds, but most of them had to be less than 5 seconds. And it was not a single query response time that was important to us, because this was not a data warehouse, guys. This application, we are getting 100 users a minute logging in today, and we plan to scale to 700 users logging in per minute. And so we were told, you have to go and at least test with 400 concurrent queries running to make sure that we'll be able to scale out and support the kind of market or the kind of business that we have. So I just wanted to present a slow SQL, against our database. So look at this SQL. It's running against one denormalized table. It says the home equity percentage is 50. Home equity value is 400,000, mortgage amount between X and Y, and estimated value between X and Y. Guys, none of these columns had an index, because as I said, we just took some of our address elements and went and created indexes for it. A query like this would take 8 minutes for us. And you know what? I remember people saying, who's going to be buying our stuff? We are at 8 minutes, and any permutation is taking such a long time, and where do we go with this? So at that time, I think we reached out to, let me show you the other query, which didn't click at the last time when I clicked this little clicker. An address query, because we didn't have, again, index on every column. Things like street directions and place name did not have columns. Some of our data elements had columns. A query like this was at 10 seconds, which in today's day and age is a pretty bad number. We didn't want to be here. We looked bad. And I think that was the time my boss told me, let's try out different technologies. Let's try out MemSQL. Let's try out Elasticsearch. And for some reason, we reached out to Sunil and his team with columnstore technology on SQL Server to see which of these three performs very well. And I have to say that the POC that we did with SQL Server 2016 had absolutely phenomenal results. It was an out-of-box solution for us without any code change. So, we have this relational row store table. It can support B3 indexes. It can support the full text index, which was very sensitive to our owner name searches. Owner names are perhaps one of the most important search that our business has. And then also, the row store had the spatial index for our polygon-based searches and our radius-based searches. And we went and we created a non-clustered index on this table, and we removed the spatial index, the spatial columns in this index to see how does it perform. And I have to say that no changes to our application, no stored procedure change. The query optimizer was very smart and intelligent to blend these indexes. It could take the spatial index and blend it with NCCI. So here you have a spatial query that could be blended with other data elements running, I'm going to say 2 seconds, but most of them are under a second right now. Most of the queries that the user runs and says, in this zip, give me some properties that are listed and are in foreclosure or of this sale amount. All those searches are absolutely instantaneous for us. And so this looked like a beautiful solution for us. It was out of the box. Everything was great. But guys, our company was still not in SQL Server 2016. You have my boss and his boss nagging us for that performance. Going to 2016 would perhaps be in 2017 next year. That's what the roadmap is. So we said, let's trick 2014 to help us out right now. And we went and we did something which I think is very, very neat because we've gone live with it and it looks pretty cool. So then in 2014, what we did is we have 2 stores. We have one row store, and all the lovely indexes in row store, like the spatial and the full text index and B-tree indexes reside over there. And we also have another column store store for us. So 2 rows, there's a row store and then there's a column store with exactly the same data. Of course, the column store does not have the spatial columns, and those are the only columns that are not there, but other than that, they're duplicate copies.
So Sonika, let me interrupt here. So this is actually a very important point. When we created the non-clustered column store index in 2016, we could exclude the spatial index, and you know what I'm saying? So those columns do not have to be included. But with cluster column store index does not support that data type, we had to create 2 tables. So that is a solution for 2014.
Yeah. And so we went with this hybrid approach. We have the clustered column store index and also the row store. And we put the full text in the spatial index. And then we had to change our stored procedure to put the queries into the right table. So for example, our count queries go to column store. The count queries are absolutely phenomenal with column store. Our spatial queries go to the row store. Our full text queries go to the row store. And when we have to do record retrieval and or blend the spatial queries with other data elements, we've gone and written our queries like this. So I just wanted to share this, where we say, select everything from row store where property ID in, and we match it with the property ID, and put the rest of the filters in column store. We play the same thing with our full text indexes, where we say, give me everybody in United States with the last name Warren, and the person who has a mortgage amount of 500,000, all of the other filters go to the column store. So this hybrid query became our silver bullet. We are live with this. And the results that I want to share are so neat. So at 6 p.m., we decided to change our, change our store procedure and see what really happens. So think about it. We had our 3 boxes, the database boxes, at 22% CPU usage, queries running at 8 minutes, 7 minutes. We changed our SP right at that time, and the CPU usage dropped down to 7% right off. Everybody was happy. Right off, right? The performance of the queries looked phenomenal for us. Of course, the store is, as Sunil had pointed out before, because the column store, the way it stores the data in the pages, it's much, and it's compressed. There was a huge improvement in the storage. We went from 560 gigabytes to 44 gigabytes. CPU consumption, this, guys, is very, very important to us. Went from 23% to 7%. We have 3 boxes. We're planning to convert one of our boxes to be a loading server right now. And we went from 2 minutes to 2 seconds. You know, most of our queries are definitely under a second. 2 seconds are the ones where the user goes haywire. He starts building searches with 15 attributes or 20 attributes. And there are some searches when they pull in 40 attributes, which go to 10 seconds too. And that's phenomenal for us. Thank you so much.
Thank you. Questions for us?
No, we do not. This is not a data warehouse kind of an application. We just have one denormalized table with a huge amount of concurrency.
Right. So the question is that is column store only useful for star schema? And as we know, in the real world, there is no star schema in a very textbook style, right? We have seen so many variations. In fact, the thing that you saw with First American, it was not a star schema, it's a one big table, right? So the column store is able to search, query large amount of data in a very efficient way. So we have deployed column store technology in a non-traditional analytics scenarios. So my recommendation is, if you have tables with millions and millions of rows, and you're doing complex queries that is taking time, you should try to play with column store.
I was just going to point out, your question was, are column stores useful in non-star schema databases? This is a prime example of how they are.
That's right. That's right. That's right. And I think the thing that is important is what Sonika was pointing out, 150 million rows, right? It's like not a mean number, I mean, it's like a 150. And we are able to query with huge amount of predicates under 2 seconds. I mean, that is phenomenal. And here is actually one important point, ETL, which Sonika was talking about. I mean, they had, I think, approximately 15 indexes, right?
Yeah.
Before they moved to the solution. When they moved to cluster column store index, the number of indexes went down. I don't know how many you have.
We just have one
index.
One index.
So what it means now for ETL, if you have only one index, I mean, all of us have done ETL, right? I mean, if you have that many indexes, it'll be blocking, locking, you drop, and so what I'm saying is your ETL simplified, your queries going through amazing performance, and the storage is 13 times lower. I mean, this is like Merry Christmas, right? That's what it is. That's right. Yes, sir. Okay, so the question is a column store page compressed? It is not. The page compression is designed for row store. This is a technology we introduced in 2008. The column store actually is not storing data in pages in a traditional sense. What it does is it's storing, let's say, 150 columns. So each column is stored independent of another column, and we compress it, in this case 13 times, and that compressed data is sitting in a lob storage underneath. Lob, of course, is broken into pages, but it is not the pages we are thinking about. And when we read the data, we bring the data into memory and process that, all these queries. So that's what we do. Did that answer your question? Okay. Yes, sir.
Yes. It was truly an apples. And you know what? We gather our statistics on a daily basis. Those servers would be at around 10 a.m. in the morning until 7 p.m. in the evening, be at 22 to 23% usage, mainly because full table scans were happening for 7-8 minutes, right? And the queries were taking much longer time. And as soon as we replaced the SP, and this is pure reality, the CPU usage dropped, and it stayed so the next day too, with 100 users logging in. Yeah.
Related to CPU, just curious, some people would say 22% CPU box is losing. Why not consolidate into one instance?
I think because we load balance and we also have to have redundancy, and that's why it's, we do have that concept across the board so that we have a backup plan.
Right. And I think one more thing, Jimmy, is important is they want to go to 800 users, concurrent users, right? If the CPU is low, they can push a lot more users on the same box, right? That gives them a lot more flexibility. And I think that is also pretty important.
Yeah, absolutely. Yeah. Oh, that's a very good question. So it's 8 cores, 256 gigabytes RAM, and we have SSDs. We have our secondary storage is SSD. Yeah.
All right.
Of course.
Yeah. Great questions.
Yeah.
Sorry, a question.
Did you also look to see what the total I/O difference was? Like how many I/Os were you doing before when it took 8 minutes or whatever versus 2 seconds?
We don't have the statistics for that, but it definitely dropped, right? Because it's so compressed. We didn't gather the statistics for that, but it definitely dropped. Yes.
Right.
Yeah, absolutely.
Right. I think I'll make one more point since you asked about this I/O, right? When you store the data as rows, let's say 150 columns and I want only 5 columns, with row store I have to read those 145 columns as well because you cannot say I just want those 5 columns. But now the data is stored as columns, we can only fetch the columns that we need. So we can reduce I/O in a very significant way, plus the compression.
Yeah. Absolutely,
yeah.
absolutely.
You want to propose stand and face them so you can,
Yeah.
can hear it. A question there. When you say cardinality of the column means how many distinct values are there in a column? Yeah. So if it is a lot of repeated values, fewer distinct values, you will get much better compression, right? I think it will be better speed, but I can't quantify how much better because let's say I was storing 10 for million values, I can process that much faster than if I had distinct values.
But I want to point out one thing there. In 2014, all the integer and the number-based column searches are blazing fast, but the text-based searches are very slow, which have really improved in 2016.
Right.
Yeah,
So,
that's
yes.
another thing. That's another reason to go to 2016.
Right. The Sonika pointed out, I mentioned string predicate push down. In 2014, string predicate evaluation was not as performant. And in 2016, we invested heavily to make that performant. And the reason is, if you have to design your data warehouse or any table from scratch, you can do the best practices, right? But a lot of applications grow organically. So there are string columns, which should have been integer columns, surrogate keys, stuff like that. So the real world is strings are there, you like it or not. So we need to process those well. So instead of fighting a better design, we try to solve the problem. Whatever customer has, we need to do well. So that was the thing. Sonika, thank you. Thank you for coming. I want to invite Yunus and I. Yeah, he's coming. So Yunus and I met in a very interesting way. Yunus actually works for a consulting company in Switzerland. And they were consulting with a bank, not bank, it's a health insurance company in United Emirates. And somehow they were evaluating SQL Server 16, and Yunus contacted me for some questions, and we just worked well together to make that customer successful. And Yunus is here to talk about that customer success. And in fact, you have a live demo. He's going to log on to their website, like the solution that is running, and to show you the workload in action.
Okay, thank you, Sunil. Okay, hi. My name is Jonas Asikainen. I work for D1 Solutions. We are a Switzerland-based consulting company who focuses on data-driven value creation. In this presentation and the demo that it will follow, I'm going to be talking about our customer project, Daman National Health Insurance, who is the leading health insurance company in Abu Dhabi, UAE. The scenario we had was customer has a traditional data warehouse. Well, maybe not quite traditional. We are not doing stars. We're actually having a holistic, multi-dimensional model with snowflake dimensions and so on. We have around 100 target tables in the data warehouse, and these are being sourced from 200 or more different source systems and source tables. The largest tables have more than 2 billion rows, and the queries, the end user queries typically involve multi-table joins. One might ask why this kind of a data warehouse data model. The reason is Daman wants that their business, the analysts, they can look at the data from all the perspectives. For example, the claims that incurred this year with respect to the premiums that Daman earned, or how are the facilities charging with regards to their contracts. All these questions, if you have separate silos, they are very hard to answer, but with this kind of data model, they can address these questions. This data model, on the other hand, naturally puts a big load on the database that is running on. So I'm showing here a sketch of the system. We have, to the left, we have the business users that fill the data in the claims processing, all that kind of stuff that's happening in the source systems. We are getting live updates into our landing zone from there over CDC or web services or even in batches for CSV files. We're processing the data in the ETL chain in the landing and preparation zone, and finally we're pushing the data into the end user data warehouse, which is the focus of this talk and the focus of migration project we did over there. That's the UDM that is contained in the red line. And this is the database that all the end users access then with different reporting and analysis tools. Okay, can you, oh, I have it. Typical queries look like this. So we have a big fact table, maybe 2 big fact tables. We may have linking tables between them, and then we have dimension tables. Then we have certain, okay, too fast. Certain queries that involve even more tables. So in this particular example, we have like the base fact table with around 150 million rows. It's linked to kind of a line item type table with 500 million rows, and then to some other fact tables and big dimension tables with up to 20 million rows. And these queries, these are what the analysts, what the end users run and what they need to shape their business. So the customer was facing some new requirements, more performance, because it gives you more insight. What does this mean, more insight? And what does it give you? If you have insight into your business, what's happening, why it's happening, you can leverage this, for example, with the negotiations with the hospitals, and that's directly a big impact to your business. So instead of having the data analyst wait for the results come up from his query, and maybe kind of indirectly having him to go for another cup of coffee in between the queries. He just sits there, results are there, and the line of thought doesn't get cut. So while you get more input, more information, more performance, just by having a faster database engine, you get also more productivity, and this is what benefits the business. And it also, if the database is good, it's also going to benefit the DBAs because they have less complaints about the poor performance. So they really wanted to have the common queries run in a few seconds and then the complex queries to run in a few minutes, and that was the requirement. The challenge is with the solution they had at that time, it's using also competitive technology, columnstore, but from a different vendor, and it was not able to keep up with the requirements and increasing demands, because while asking for more, they were also having more people ask for more, so the user base was expanding. So we were basically looking for a solution that can keep up with the increasing workload for the next couple of years, and as an approach, we proposed the customer, let's do a benchmarking. Let's do a testing of performance of different database vendors, how they work. And our approach was, okay, there are existing TPC-Age and so on benchmarking frameworks, but what if it doesn't work for you? So what we did is we took a replica of the data model with the central tables, not everything, because it's a big thing. We created tables with same sizes, same characteristics, for example, distinct number of references to other tables and so on, and we filled this with synthetic data. We did this exercise in the cloud because we were totally flexible to set it up at our own pace, and we ran performance benchmarking results, which I will show on the next slide. Following this POC, this benchmark, we ran a POC because the benchmark was successful, where we, in a time span of 6 to 8 weeks, basically replicated what we had on production on the currently running system to the SQL Server 2016. And we started testing with the productive data, all the things that need to be tested over there. And after we saw that this POC is successful, we moved to a phase of parallel operations, where in the time span of 2.5 months, we actually had daily load on both systems. We had analysts run their queries on both systems. We measured things on both systems, and by the end of this period, we were convinced that this is the way to go. So actually, pretty much around the time where the SQL Server 2016 was publicly released, we then went live with it. So how does our data warehouse look like now? We have all the fact tables and all the dimension tables actually as well on clustered column store indexes. We have primary keys to ensure integrity, and also we have foreign key constraints. They are not implemented as indexes, but just as constraints to make sure that, that the integrity is there. I'll show you examples of performance results we got from the benchmarking.
So, let me interject. So the chart that you see here, actually it's the most exciting chart that we saw inside SQL Server development team. And I'll tell you why. Column store is not something that Microsoft created. Column store came from universities, and column store technology has been adopted by our competitors. You can say DB2, HANA, right, Oracle, and on. And Jonas' team was the first team that did the POC across all our competition, including SQL Server 2014. Okay, and the number you see, I think Jonas may be talking about these performances.
Yep.
We cannot show which vendor it was through legal reasons, but you can see we pretty much beat all the competition.
Okay, so I'm going to say a few words on this results. The SQL Server 2016 was a clear winner in both cases. So the key information access query, which is a long-running big query joining huge number of tables running over huge amount of data, as well as the typical end-user queries. We have on this chart, we have a in-memory solution. I have to say this solution required twice as much RAM on the box in order to just be able to run with the data. We have other column store technologies and from known vendors. So overall, the performance factor, the gain you see here, it's quite good. And for me personally, two main things from this chart. SQL Server 2016 beat in memory in both our end user scenarios, and it beat 2014 quite clearly. Okay. Then I'm going to show some results on the testing period and the production period. For the ad hoc analytics, like daily running queries from the analysts, I don't have the comparison because we actually sunsetted the current solution. Anyways, we are seeing a good improvement, and from the query store, we can derive statistics on the long-running queries. And emphasis here is on the long-running queries. I have a collection of around 200 queries, distinct queries. Around 130 of them run in less than 20 seconds. And these are the long-running queries. Customer also has weekly reports. They have around 50 jobs that are scheduled each week. And among these 50, we see an improvement of 60%. So the execution time goes down from 28 hours to 10 hours only. And finally, there's there's several, but I'm showing as an example, one business tool which runs at the end of the month. And here we get a 5 times improvement in the speed. So instead of waiting 2 days to get the results to the business, we're done in 10 hours. Okay, I'm going to log into the system. And I will show you a live demo on the customer's productive environment. Do you see it? Okay. As far as hardware is concerned, we are running Pure Storage SSDs. We have 16 virtual cores and around 150 gigabytes of memory. Okay. Let me try again. Looks like the.
Yeah, so while it is coming up, I want to add one more information. You carry on with this thing. So the Damon, that is a customer, they were so pleased with SQL Server 16. They said we will look now, step back, and other applications in their environment that are running our competitive platform, and they want to put SQL 16 as an option. So in fact, they are very actively looking at what we can move from other vendors to SQL Server 16. So we are pretty excited about that as well. And this workload, Eunice, is going to run on the production system, right?
Yeah.
Okay.
I hope that it comes up quick. Sorry about this inconvenience. Okay. I tested it several times before the presentation, you know.
Okay. Okay, while Eunice is doing it, any questions on this part? Happy to take questions.
Yeah, I mean, I have time. Okay, now we're talking.
Okay.
All right, so just to show you that we really have some data, I do some counts. Yep.
Expand it.
Sorry.
Yeah.
Yeah, I will do that. Is it better? Okay. So we have 3 big fact tables. The first one has 2.75 billion rows. Second has over 700 million rows, and the third one has over 200 million rows. So that's the kind of data volumes we are talking. I show you to begin with a query on the largest table. So we are joining a fact with 2.75 billion rows with two small dimensions. One has around 100,000 rows and the other one has around 100 or so rows. And we're basically doing slicing and dicing live with these couple of tables. So I'm aggregating two orthogonal dimensions and seeing what it looks like. We're done. We have around 3 seconds.
Isn't that phenomenal?
I mean, I wouldn't dare run this query with a previous solution. Okay, so the next one is a little bit more complicated. We have a claim table with around 200 million rows. With this resolution, you can't see the full query, but basically you see it's involving lots of joins. And what I'm doing again, I kick it off, I'm aggregating data across a few dimensions, and the biggest of this dimension has 20 million rows. And while I'm talking, the results are actually already there. So again, a few seconds, which I think is pretty good. So let's move on to the next case, where we have two big dimensions with the same big fact table. So 200 millions, 30 millions, 9 millions, and then some smaller tables. This is a typical query, basically. How much money per hospital per type of invoice you are getting, you are going in because of the insurance claims. And there's the result. Now it's because of many joins, so 7 seconds, but still not bad, I think. And this is the last one. I am now including the claim line items. So all the diagnoses, all the operations that were done, all the drugs that were prescribed, and so on, in the same query. That's pretty much it. We are done again in under 10 seconds. This is kind of performance we are seeing, and our customers are quite happy with it. And just in case you didn't notice, I obfuscated all the data, so you don't really know what it was about. Thank you.
Yeah, thank you, Jonas. Question?
It's really a comment. As you know, I've been a fan of columnstore ever since it was introduced. And it's just amazing to me. This stuff, these aren't just cherry picked. Sure, they're nice examples. But columnstore is such a game changer for so many apps. And so many people aren't leveraging it. It should be the default index of choice for so many applications.
That's right. Right.
Not something to try in your spare time. Implement it from the ground up, see what it does.
Right.
It's so magical.
Yeah. I think one of the messages we want to communicate is that columnstore, just try it, because in many cases you do not need to change anything, right? And see the numbers for yourself. I'm not saying every application, everything will work like magic, but it's a pretty compelling argument. Second thing that is important is the columnstore technology. I mean, I was at a customer site. They said, well, this vendor has a column store, you have a column store, so what's the big deal, right? I said, you know, there is Toyota Corolla and there is BMW, right? I mean, they're both cars, but one is high performance. So definitely give it a try. We believe that our technology is the best in the industry. You saw Yunus, you know, they did a POC across multiple technologies. I'm sure you will find variance. Some workloads may run faster with our competition. I'm not saying that. But I'm saying is consistently we have seen, I think Sonika was talking about, that we have seen a pretty good numbers. So let me go to the last slide. And now how do I do it? Okay, I'll just do this way. So I had one more customer, but I'm just going to skip that. So I think I'm hoping that we are able to convince you that the columnstore technology v16 is a pretty compelling technology for you to think about and try in a workload. And other thing that I want to say, I work for SQL product team. I've been with them for 14 years. And I moved to a team called SQL Tiger team. And the only role I have is to make our customers successful. So if you are thinking about trying something in SQL Server and you need to talk to somebody in the product team, look me up. I'll be more than happy to work with you. And my email is actually in the title slide, and you will be able to download that. With that, we want to close the session. I want to thank Sonika, Mika, and Yunus for coming from several, you two came from different countries, so to just be here to share their stories. Really excited to be here with them to talk about SQL Server success. Thank you so much. Yeah.
Thank you.